Yeah, welcome to this lesson. And in this lesson, we'll be treating chemical bonding. Chemical bonding. So, specifically, we'll be treating ionic bonds. So, let's see what we have. So, first, I will start by an introduction defining what ionic bonding is. So, ionic bonding occurs when an atom transfers electrons to achieve full outer shell. So, it's not just um, it's not just the transfer of electron that you call ionic bonding. So, when the transfer of electron is going to achieve the a full outer shell, that is what is called ionic bonding. So this is typically the kind of bonding that occurs between metals and non-metals, and it is a transfer that creates oppositely charged ions. So it creates species that are known as anions and cations, where anions are negatively charged, then cations are positively charged. So when ionic bonding occurs, these two species are being formed, and because of this strong pull, the strong attraction between positive and negative, that's the anion and cation, it makes these ionic bonds a strong form of bonding. So, and it leads to the formation of ionic compounds. So these bonds are fundamental in understanding salt formation and crystal lattice structure. So let's head into the formation of ionic bonds in depth. So in ionic bonds, the ionic bonds form when atoms, usually a metal, loses one electron or more to become positively charged cations, while another atom, typically the non-metal, seems to gain that electron or those electrons to become negatively charged anions. So when these new species are formed, the anions and cations are formed. These anions and cations, being oppositely charged, would have a kind of attraction for each other, and this attraction is known as electrostatic attraction between the two species that are being formed. And as a result of this attraction, the bond is being formed, where you have negative being attracted to positive, and this attraction is what is being called the ionic bond. So, properties of ionic compounds. So, these ionic compounds, they are known to be crystalline solids. They are known to be crystalline solids with high melting and high boiling points, and they are also known to conduct electricity when they are in their molten state or dissolved in water. And this ability to conduct electricity is due to the mobility of ions. So these ions, they are species that are charged. So we know that electricity is being conducted when there is a movement of a charged species. So when you have movement of these ions that are being charged, we tend to see a movement or a creation of electricity. So these compounds are often soluble in polar solvents and typically brittle in their solid form. So they are soluble in polar solvents, like solvents that are kind of positively or negatively charged, solvents like water. So they are known to be soluble in these kinds of solvents, because polar solvents would always polar solutes would always be soluble in polar solvents, and non-polar solutes would be soluble in non-polar solvents rather. So let's see some examples of these ionic compounds. So some common examples of ionic compounds include sodium chloride. This is the most popular ionic compound that they use mostly in most of the explanations. Next is magnesium oxide and calcium difluoride. So each of these compounds showcase a fundamental principle of charge neutrality. So when these two entities, the anions and cations, when they bond together, forming a single compound, they form a neutrally charged compound. A neutrally charged compound. So, and these charges are equal. They have a total positive charge, and this positive charge is always equal to the total negative charge, leading to charge neutrality. So, um, another concept we're talking about in this lesson is the lattice energy and stability. Lattice energy and stability. So lattice energy is the energy that is released when ions bond to form a crystal lattice. So when you hear the word lattice energy, they're talking about the energy that is being released. So it's the energy that is being released when ions form to form a crystal lattice. So the greater the lattice energy, the more stable the compound, meaning as ions come together to form bonds, if they release a strong energy, it means that the bond that is formed during that formation is going to be a very strong bond, and these kind of bonds are usually called crystal lattice bonds. So the greater the lattice energy, the more stable the compound, and lattice energy increases with increasing charges on ions. So meaning when you have a charge of +1 and a charge of -1 forming, the lattice energy would be significant. But when you have a +2 bonding with a +2, as the charge size, the charge of the ions are increasing, it makes the lattice energy more strong, like it makes it stronger. So also another characteristic that makes for stronger lattice energy is smaller ionic radii. So species with smaller ionic radii will tend to form stronger stronger lattice crystals. So because the size, as their sizes are small, it makes them come closer to themselves, and when they come closer to themselves, it means their nucleus is going to be attracted more to itself, and this kind of attraction would cause stronger bonds. So let's head into factors that affect ionic bond strength. So the strength of ionic bond depends basically on the charges of ions. So it depends on the charges of ions and also the distance between them. So the closer the distance between these species, the stronger the bonds, because the nucleus of the positive species is what will be attracting the electrons on the negative species. So if the distance between them is smaller, it means they will be able to glue to themselves more. The strength, the pull will be stronger. So but if the distance is farther, it means it's difficult, it will be more difficult to keep this kind of bond, just like as if you're trying to talk about long distance relationship and short distance relationship. So when you have short distance relationship, it's easier for them to have a kind of bonding union. So but when you have a long distance, it's difficult for that kind of relationship to thrive, though some conditions can make them happen to be strong. But for this case, we're talking about, we are having the overview that closer distance means stronger bond, while longer distance means weaker bond. So also charge of ion also it comes in play. So the greater the ionic charge, and smaller ionic radii, the stronger the electrostatic force and the stronger the ionic bond. So in conclusion, ionic bond is a crucial concept in chemistry that provides the basics for understanding wide range of compounds and also materials. So through electron transfer, atoms form stable ionic structures. So take note, when you hear ionic bonds, always your mind should always reflect to electron transfer. So when we go to covalent bond, you will see the difference between electron transfer and the one that happens in case of covalent bond. So these electron transfer forms ionic structures, and these ionic structures are characterized by strong electrostatic interaction and distinct physical properties. So that will be all for this lesson, and I'll be saying goodbye.